Welcome back. This is an Aleks training video on predicting the relative electronegativities of an atom. So, electronegativity is another one of the trends, the periodic trends that we've talked about before, where you have the arrows going left or right or up or down. Electronegativity just gives you an idea of the amount of control, I suppose, an element has over the neighboring valence electrons. Let's imagine that you are playing tug of war and you are sharing the handkerchief tied in the middle of the rope. Okay, the strong person is going to have more of the handkerchief than the weak person. Okay, because the strong person is able to pull that handkerchief to himself more than the weak person. If you are sharing a peanut butter sandwich with somebody greedier than you, chances are that it's not going to be an equal sharing. They're going to get more and you're going to get less. All right, so if you have two elements that are sharing a bond, they're sharing two electrons, whichever one has the greater control over those electrons are going to have those electrons more in its yard than the other person's yard. So it's like a whole hockey team sharing a trophy. All right, so what does that mean? Whoever the ball hog or the hockey puck hog is going to get the trophy at his house more than the other players, if that has anything to do with your understanding of this. So electronegativity is the ability for an electron to pull, an element to pull an electron to itself. So think of it, it has a greater pull than the other element. So it has a higher grade electronegativity. It's electronegative. That electron is to itself more. Okay, so it's more in that person than yours. All right. So I've given you a schematic here of the relative electronegativities, and you can see that fluorine is the highest. So and cesium is the lowest. Well, that's showing you that it's generally trending towards increasing as you go across the period, and it generally increases as you go up towards the top of the periodic table. So up and to the right is higher electronegativity. Any of those electrons will share unequally. Any of those elements will share an electron pair unequally. Okay, so it's going to go more towards that one than the other one. So for that reason, you need to kind of know to the right and up is higher, to the left and down is lower. So they're going to have you rank these three, and then you have two problems. Okay, so the first one is bromine, arsenic, and selenium. So where are they? Okay, so bromine is in group 7, that's here. Okay, arsenic is in group, I've made it so small I can't see very well. It's in group 5 here, and selenium. So we're talking about these three. Okay. Well, which one's going to be the bigger one? The one towards the most to the right. So bromine will be bigger, then selenium is next, and then arsenic is next. Okay. So let's write it out. So we want bromine to be first, and then selenium is next, and then arsenic is last. Okay, how about the second line? Second line is selenium, oxygen, and tellurium. Okay, so selenium is in group 7. Okay, right here is group 7. Tellurium is group 7, lower, and oxygen is in group, no, they're all in group 6. Sorry, not 7, 6. So this is oxygen, tellurium, and selenium. Okay, they're all in the same group. So you want towards the top. So that we want increasing elements in order of decreasing. So you want the biggest first. The biggest would be oxygen. Okay, so you have oxygen first, then you have selenium second, then you have tellurium third. Okay, so not bad. I think this is pretty easy, straightforward.